Hi students, we'll now talk about the proper hypothesis testing procedure that we need to follow whenever we are asked to test a particular hypothesis regarding any population parameter or regarding any qualitative perspective. So, for this purpose, what I'm doing, I'm selecting this question number 9.41. Part of this we have already discussed. We can recall in the connected previous lectures video that we have stated H naught, H1, and we have decided about the nature of the test in the previous exercise for the same question. The question is, according to the Census Bureau publication construction reports, the mean expenditure per residential property owner for maintenance and repairs in 1983 was $280. For last year, a random sample of 40 residential property owners revealed the following expenditures in dollars. So this is the data that we are given about the 40 residential property owners that they have spent the amount on maintenance and repairs. Now we are asked for, do the data provide sufficient evidence to conclude that the last year's mean amount spent for maintenance and repairs has increased over the 1983 mean of $280? Here we are given an assumption regarding population standard deviation, and we are given as assume sigma to be equal to $265 and perform the hypothesis test at the 5% significance level. We are also given the sum of the data as 11,644. So I'm now going to note down the data. N equals 40. Sum that we are given as 11,400 644, 11,644, and using this we can work out the mean value, and you can check with your calculators that 11,644 when divided by 40 gives us the mean value of $291.1. We are also given sigma value, which is $265. Now what we need to do, we need to follow all steps of hypothesis testing procedure. And there are 7 steps that we follow whenever we try to answer hypothesis testing and its results in a question. So step number 1 is the same with what we have done already in part A and part B of the previous exercises. So we need to state in the first step the null hypothesis and the alternative hypothesis. Mu equals $280 and mu is greater than $280 because the hypothesis says, or the testing statement says, increased over the 1983 mean of $280. Then the next step that we state, we call it level of significance. This LOFS stands for the level of significance at which we are performing the hypothesis test. And what is a level of significance? Level of significance is simply a probability of rejecting the null hypothesis. Okay, a level of significance or alpha can be defined as the probability of rejecting the null hypothesis, H naught. It does indicate that we are not dealing with a certain scenario, and right there in advance we keep some room for the rejection of hypothesis testing in the form of probability. And probability over here for rejecting the null hypothesis is given as 0.05. If the probability of rejecting the null hypothesis is 0.05, then the probability for the non-rejection would be 0.95, that is one takeaway 0.05. So after stating the null hypothesis, we need to now decide about the test statistic. That's step number 3. Over here we need to look at the data, and we will apply the same norms or rules and regulations what we have applied in case of estimation procedure when we were asked to construct 1 minus alpha percent Ci for the population mean mu. We had to look at the data or sample size. We had to look at the availability of standard deviation and an assumption regarding the behavior of the population. Assumption we don't need if the sample size is large enough, as this is the case over here in this example. Sample size is given as 40 and standard deviation is also known, and we are testing for population mean. So we need to refer Z distribution or use Z distribution for this hypothesis testing. And the formula is Z equals X bar minus mu divided by sigma divided by root n. This is the formula for Z that we use. Now step number 4, we need to define critical region, that is the condition under which our H naught would be rejected. And here in this step we will incorporate the information that we are given in step number 1, step number 2 and step number 3. In step number 1 we are given the condition for the nature of the test, and it is a right tail test that we can indicate or identify on the basis of the greater than sign. We are given an alternate hypothesis. Then we need to make use of the level of significance, that is the probability given for rejecting H naught. And since it is a right tail test, we need to assign this entire probability of 0.05 on the right tail part under the curve. And what should be the shape of the curve? That is indicated with the distribution. Because the distribution we are using for this hypothesis testing, therefore we need to draw a bell-shaped curve. And then what we need to do, we need to consider this probability and the nature of the test. The nature of the test says it is a right tail test, so we need to take the right tail area and we need to draw a border line in such a way that above this border line we should have the area or probability that we are given as the level of significance to be used for this hypothesis testing. And we usually shade the rejection the region in which we will assign the probability of level of significance, and we call this region as rejection region for H naught. RR stands for rejection region, and here NRR indicates the non-rejection region for H naught. And here at the border line we need to indicate the Z value with the related probability. Z.05 value is 1.645, and I have used this value with positive sign because it is located on the right part on the curve. If it was located on the left part of the curve when we are going to perform left tail test, then we need to indicate the same value with negative sign we all know. And we need to also write down in the form of statement the condition under which H naught would be rejected. H naught would be rejected if Z calculated, this CAL subscript on Z is indicating calculated or computed value that we will compute from the data or the information given in the data when we substitute all the values in the formula of z. So this value, what we have got over here as a critical value, we call it tabulated value. This is the z value obtained from the z table on the basis of the probability given for the level of signal. And we indicate this with greater than sign because H naught would be rejected if our test statistic value or computer value of test statistic will fall in this region. That should be strictly above 1.645. So this is how we write down the fourth step of hypothesis testing procedure. Now step number 5, which is of computation. Over here in this step, we will substitute each and every value in the formula of z. Z calculated or Z computed. X bar value is 291.1. This mu value we borrow from the null hypothesis. And now you may know the reason why we have not indicated this with less than or equal to as a contradiction to the sign we mentioned in H1. Over here it is greater than. Previously, initially, we have indicated it as less than or equal to, but when we indicate it as less than or equal to, so for less than implication or application, we have a variety of values that we can substitute in place of mu, as we have to borrow the substitution for mu here in the formula from H naught, and if we indicate less than sign, then we can have 279. We can have someone may come up with 285, 275. Someone may say that I am going to substitute it as 10. So to restrict that value to a unique value, what we have to do, we have to use equality sign for that reason here in H naught, because as we have discussed already, the H naught or using equality sign in H naught is sufficiently defining the contradiction for H1. So now we substitute 280 here. We can substitute 265, which is the standard deviation value, and divide by root of 40. When we compute this value, you will get your answer as 0.265. This is the computed value of z. Now compare the location of this value under the curve that we have defined over here. May be located somewhere over here. So 0.265 will be located in the non-rejection region. Therefore, it does not suggest to reject our H naught. So we write down in the next step our decision based upon the same information. So what we do, we specify the reason since Z calculated does not fall in the rejection region. Therefore, H naught is not rejected. This is how we write down, and we can specify the reason that Z calculated is less than 1.645. It's not greater than 1.645. So this is how we write down decision with the justification that why we are not rejecting or rejecting the null hypothesis, whatever the situation is. Now in the last step, we write down conclusion. And in conclusion, we need to strictly state the implication of this non-rejection on the question or the requirement of the question that regarding which we were testing the hypothesis. We were asked to test the hypothesis whether mean expenditures exceed $280 or not. So what we do For this, to answer this, we have performed a test, and the test has ended up with a result. So we state it accordingly as the test results are not. I'm negating this because we have ended up with the non-rejection. Therefore, we are negating each and everything in the conclusion part accordingly. The test results are not statistically significant. Now we need to state the level at which we have performed hypothesis test at the 0.05 significance level. We need to strictly state the level at which, or the significance level at which we have performed the test. Because when we change the significance level, the C value will be changed and our result may be different in that case. So at the 0.05 significance level and data do not, again we are negating this, do not provide sufficient evidence. If you can focus, you can easily recognize these words were given in the question right there. And data do not provide sufficient evidence to conclude. Now what we do, we need to write down the same statement what we are given for the hypothesis testing, and the statement was and data do not provide sufficient evidence to conclude that the mean expenditure mean that the last year's mean amount spent for maintenance and repairs has increased over the 1983 mean of $280. So I am writing down the same statement over here to conclude that last year's mean amount spent for maintenance and repairs has increased from 1983 mean of $280. So this is how we can answer the hypothesis testing question following these 7 steps properly. Now I'm using and selecting another question in which you will be able to understand the implications of data or any changes in the sample findings, that how sensitive the changes in the sample to our results, our conclusion, our data analysis findings would be. So I'm using this question 9.45. It is regarding a dog food manufacturer sells 50-pound bags of dog food. Suppose you randomly select 75 bags and find that X bar is 50.11 pounds and standard deviation of sample is 0.84 pounds. So now I'm going to first write down or note down the data. 9.45 is the question, 75 is the sample size, 50.11 is the value of X bar that we are given, and standard deviation of the sample is given as 0.84. And what we are asked for, would you be inclined to believe, in part A we are given that would we be inclined to believe that the actual mean weight mu of all 50-pound bags of this dog food differs from the advertised weight of 50 pounds. Perform your hypothesis test at the 5% significance level. So again, alpha we are given as 0.05. Now, as a step number 1, we will state our H naught, which is mu equals 50 pounds. H1 is given as mu differs from 50 pounds. So differ indicates that this is a two-tailed test that we need to perform. And for that reason, what we'll do in the level of significance step, we need to first mention alpha value. Then since this is a two-tailed test, then this given significance level of 0.05 should be assigned equally to two tail end zones to introduce or to indicate it as a two-tailed test. So alpha by 2 would be 0.05 by 2 gives you 0.025. Now as the third step, again you can look at the data. We are testing for mu and the sample size is 75, that is large enough to go for Z to be used as a test statistic. So Z equals x bar minus mu divided by sigma divided by root n. Over here we need to make a correction in the formula because if we match what we are given in the data is not the population standard deviation this time but sample. So what we need to do, we need to change this to x. Okay, and for this reason I am using an eraser over here. And I would change it accordingly. So this is standard deviation of the sample that we need to indicate here. Now, same as before, we will write down the critical region or state the critical region or the condition under which our null hypothesis would be rejected. So we draw the curve. Again, a bell-shaped curve we will draw, and this time we'll indicate the rejection regions on both right and left hand side because this is a two-tailed test with 0.025 here and 0.025 here, and we also indicate these two regions as rejection regions for H naught, and this is also the rejection region for H naught, and that's 1.96 is the Z value corresponding to 0.025 probability we all know. So we indicate 1.96 on the right tail area with plus sign. We will indicate 1.96 the same value on the left hand side with negative sign, and we state the conditions accordingly. This region is the non-rejection region for H naught, and we state it as H naught would be rejected if Z calculated is either less than minus 1.96 or it is greater than plus 1.96. Now we go to the step number 5, which is of computation. Over here we substitute the values. X bar is given as 50.11. Mu value we borrow from H naught, which is stated or mentioned as 50. Standard deviation of the sample we are given as 0.84 divided by square root of 75. Now we work this out. I am working this out on my part and you need to work out as well. That's 50.11, take away 50 would simply give us 0.11. Then divide it by 0.84 divided by square root of 75. 1.13 is the calculated value of z that we are getting. Z calculated is coming up 1.134. As again, if we compare this value with the one we have stated or mentioned in the sketch, so it is falling again in the non-rejection region. So same argument we state what we have stated in the previous question in the decision, and we state it as since z calculated does not fall in the rejection region, therefore H naught is not rejected. And over here you can state the reason that z calculated is falling between minus 1.96 to 1.96. That's the mathematical justification for that. Now we write down decision as step number, conclusion as step number 7. Same as before, we start with the same words. The test results are not statistically significant at the 0.05 significance level and data do not provide sufficient evidence to conclude that the mean weight of all bags of this dog food differs from the advertised weight of 50 pounds. So this is how we state our argument in the conclusion. Now moving to part B of the same question, we can see that in part B we observe a slight change in the X bar value. Again, they have drawn the same sample of 75 bags from the same population, but the sample indicates that X bar value this time is slightly different. It is higher and it is actually given as 50.21 pounds. So what will be the impact of this change in the X bar value on this question, it will not affect step number 1, step number 2, step number 3, and step number 4. All steps remain same with same specifications, with same working. But the change will occur only in step number 5. And what would be the change? Z calculated for part B will be different, as 50.21 we will substitute as the x bar value minus 50, 0.84 divided by square root of 75. Now when we get it computed as our answer, then 50 take away 50.21 take away 50 would give us 0.21 divided by, then we have 0.84, same value for standard deviation of sample that we are given. The square root of 75, which is the same sample size, gives us 2.165 as the Z computed. 2.165 is Z computed, which is clearly exceeding 1.96, and it is the case of rejection on the right tail area because the value is positive and it is exceeding the right side critical value in the sketch, or right tail critical value in the sketch. So we have to make amendment in the answer in that case. So I am changing the color to red and I am writing down, instead of does not, since Z calculated false, we will not indicate this, we will indicate it as does fall instead in the rejection region. Therefore H naught is rejected, so we cancel this not. Okay, we cancel this because our decision is altered, it's changed, and over here we will state it as Z calculated is exceeding 1.96. This is a clear indication of the rejection in the right tail part under the curve. Now conclusion we go for. Again we will make amendments in the, or changes in the conclusion accordingly, and we will cancel out this negating aspect. The test results are statistically significant at the 0.05 significance level, and data do not be cancelled out, and instead we state it as, and data provide sufficient evidence to conclude that the mean weight of all bag of this dog food differs from the advertised weight of 50 pounds. You can now understand how your decision and conclusion may change if we observe any changes in the sample information or sample statistic. Okay, so this is how we do it, and that's all for this session.